to multiply fractions, we're going to follow this rule written up here in blue. This is the algebraic way to show how to multiply fractions. We're going to take the numerators, which in this case are a and c, and we're just going to multiply them together. A times c looks just like this. Remember, in algebra, we're not going to use the little dot symbol very often or the X symbol for multiplication. We just kind of write things right next to each other. We're going to do the same thing with the denominators, which in this problem are B and D. We're going to multiply those straight across as well. B times D could be written as BD. So let's just go ahead and jump into this. I'm going to start by using those multiplying and dividing integer rules to decide if this answer will be positive or negative. I see one negative sign, which means that this final answer will be negative. I'm going to go ahead and make an answer box with a negative in it so I don't forget. 2 times 5 is 10, just multiplying straight across. And 15 times 4 is 60. Now I can reduce this, make this fraction better. I can just cross out these zeros. My answer is 1/6, and it's negative because there was one negative sign. Let's go to another problem. I'm going to multiply straight across. 4 times 3 is 12, and 9 times 10 is 90. I can tell this answer is positive because there aren't any negative signs, and I can tell that this answer isn't quite good enough because they're both even, which means I can reduce. I'm going to go ahead and divide by 2 on the top and 2 on the bottom. And this looks reduced, but it's actually not finished. I can divide both of these numbers by 3. 6 divided by 3 is 2. 45 divided by 3 is 15. And that's going to give me a final answer. Now, a big problem in 7th grade math is that a lot of students would have stopped at this answer. And even though this answer isn't wrong, it's just not simplified all the way. It would be not quite correct on a test. So we're going to try these same problems again, except I'm going to show you a different way to solve them. And that is to cancel out anything that you notice is on the top and on the bottom. And here's why. Let's go back up to this algebraic example. Let's say that this was 2 and 4 on the top. And let's say that it happened to be 2 and 4 on the bottom. 2 times 4 is 8, and 2 times 4 is 8. 8 divided by 8 is 1. Well, actually, any number divided by itself is 1. So when we see numbers on the top that are also on the bottom, like this 2 and this 2, we can cancel them out because they're just 1. This 4 and this 4 cancel each other out because they're just 1. And 1 times 1 is 1. So let's see what this looks like down here in a problem. Are there any 2s or 5s down here? No, but here's what I can do. I'm going to scribble out this 15, and I'm going to write it as 5 times 3, because 5 times 3 is 15. Now do I have stuff to cancel out? Yeah, this 5 can cross out this 5. Do you see anything else that we could cancel out? What if I changed this 4 into 2 times 2? I can cancel out a 2 from the top and bottom. I know that this answer is going to be negative, and what's left on the bottom is a 3 times 2, which is 6, and what will be left on top would be a 1. Remember, 2 divided by 2 is 1. 5 divided by 5 is 1. So here was a different way to come up with the same answer, except I didn't do any reducing of fractions at the end. Let's try it on this problem. I don't see anything right now that I can cross out, but what if I change this 9 into 3 times 3? I can cross out a 3 from the top and bottom. What if I change this 10 into 2 times 5? Well, that doesn't quite help me yet. Oh, maybe I do this. What if I cross out 4 and change that to 2 times 2? I can cross off a 2 from the top and bottom. Now what's left? A 2 on the top. 3 times 5 is 15, and a 15 on the bottom. Using this way, I didn't get stuck at this answer where I might think I was done, but there was really one more step to go because I did all my canceling before I started. Now, when we have to multiply mixed numbers, and you've seen this before, we're going to change them into improper fractions. An improper fraction is a fraction where the numerator is bigger than the denominator. So you've got a big number on top and a smaller number on the bottom. We've done this before. Here's how I change. 3 times 2 is 6, plus 1 is 7, and the denominator stays the same, it's 3. How do I turn the whole number 6 into an improper fraction? Put a 1 underneath that. You guys see that every day in class in our date on the board. Now I can multiply straight across and come up with an answer, or I can see if there's something I can cross out before I start. Here's one more. This is going to be a negative improper fraction. Now that I've written that, I can kind of ignore it up here. 4 times 1 is 4, plus 3 is 7, and the denominator stays the same. 5 times 2 is 10, plus 2 is 12, and the denominator stays the same. I can multiply straight across, or I can see if there are some things that I could cross out to make this easier to solve before I get started. I'd like you to finish these 2 questions in your notes. Now here's a big, scary looking problem. I'm going to do what I did in that problem right before this. I need to turn this into an improper fraction. I can see it's going to be negative, so I'm going to put that negative sign down there. 2 times 1 is 2, plus 1 is 3. Denominator stays the same. And here's another negative, put that there. 5 times 2 is 10, plus 2 is 12, and the denominator stays the same. How many negative signs are in this problem? 1, 2. That means my answer is going to be positive. Now that I know my answer is positive, I'm going to go ahead and ignore those signs. And I could multiply straight across here and do 3 times 3 is 9, times 12 is 108. 4 times 2 is 8, times 2 is 5, which is 40. You know what? I'm going to have to do a lot of reducing. I don't want to do that. I'm going to see what I can cancel before I start to go straight to an answer. I don't see anything on the top or bottom, but I can change this 12 into 3 times 4. I'm going to cross out a 4 on the top and bottom. Let's see what's left. I've got a 2 and a 5. I don't see any of that up here, so I think that's all I can do. 3 times 3 is 9, times 3 is 27. 2 times 5 is 10. This answer, even though it is an improper fraction, is acceptable. I could also turn it into a mixed number 10 goes into 27 2 times. 2 times 10 is 20. I was trying to get to 27, so that means I've got 7 pieces left, and the denominator stays the same. Evaluating. Oh, we're experts at evaluating. We remember that evaluating means that we're going to substitute a number where we see a variable. And remember that I ask you to always use bubbles. So this first question would look like this: 2/5 times bubble. And I'm going to be filling that in there. 5 bubble, bubble. -3 bubble. -4/7 bubble. And then I'm going to be able to go back and fill in these values. I'm supposed to use 3/5 for x and -5/9 for y. Now I see a couple of problems here that have whole numbers. How do I turn the whole number 5 into a fraction? I put a 1 underneath it, just like you see in the date on the board. And I turn this -3 into a fraction by putting a 1 underneath it. I'd like you to complete these 4 problems in your notes. Inverse is a property that we've talked about, and so I'm going to just do a quick refresh your memory on what inverse looks like. An inverse, another word for inverse when we're talking about multiplication, is reciprocal. And this is going to be really important in a couple of lessons when we learn how to, when we learn how to divide fractions. So the inverse of 3/4 will give me an answer of 1. The inverse of this will give me an answer of 1. All of these will have an answer of 1. You just need to figure out what goes here. And I'll remind you that the reciprocal would look like this. Now, why does this work? 4 times 3 is 12. 4 times 3 is 12. What's 12 divided by 12? 1. What would go here? Well, first I need to turn this into a fraction. What would the reciprocal be? 1/2. Why does that work? 2 times 1 is 2. 1 times 2 is 2. And 2 divided by 2 is 1. You've got a couple more that I'd like you to fill in the answer. And here are 2 more problems for you to try on your own. Here's a really complicated one. I'm going to go ahead and mark this as a challenge problem, an extension problem. Try it, see if you can finish it. This one you should be able to do. This is an inverse problem. It's what I just spoke about on the last page. And if you want to play a fun Who Wants to Be a Millionaire type game, this game right here, tinyurl.com/carnesmultfractions, will give you that opportunity to practice multiplying fractions in a fun game.